Hello everyone! My first ever math video will start with Chapter 3, Equations in Two Variables, the first lesson of constant rate of change. In this video, you can identify proportional and non-proportional linear relationships by finding a constant rate of change. To begin with, let's look into a couple vocabs. The first vocab is a linear relationship. This is the relationship that have straight line graphs. For those of you who haven't heard the word linear before, to make it just a little bit easier, the word linear has a line in it. Thus, whenever I hear the word linear relationship or linear something, I kind of think about it's gonna graph a straight line. However, some of the examples will not always provide graphs to begin with. In order to prove it's going to be linear relationship, you will be using what we call constant rate of change. The constant rate of change is the rate of change between any 2 points in a linear relationship that is the same or constant. So for example, look into this table where the y is representing a number of songs, where x is representing times in minutes. Let me look into the y values to begin with. If you're looking at all of these y values, they have some sort of patterns. From 0 to become 2, I notice I'm going to add 2. 2 to 4, it's also I'm going to add 2. You'd notice 4 to 6, 6 to 8, they're also adding 2 repeatedly. Let me look at the x value. From 0 to 1, I'm adding 1. 1 to 2, adding 1. 2 to 3, I'm also adding 1. And I notice all of these are having the same patterns for your y values with your x values. Thus, your rate of change becomes you're using those numbers of the pattern. So you're using those rate of change. Now you have 2 over 1, which simplifies to 2 songs per minute. Let's look into the first problem. The balance in an account after several transactions is shown. Is the relationship between the balance and number of transactions linear? If so, find the constant rate of change. If not, explain your reasoning. So in order to be linear, you need to find whether it's going to have constant rate of change or not. If it doesn't have constant rate of change, then it cannot be linear. So for example, by looking at this table, the number of transactions. The first number starts with a 3, becoming 6. From 3 to become 6, I notice that my number increased by 3. From 6 to 9, also my number increased by 3. From 9 to become 12. So if you're having difficulty, think about this way. From 12 minus 9, the difference will be 3, and that's how I know 9 plus 3, also I'll get 12. For the balance side, I need to make sure that this right side is also constant. So 170 becoming 140, which means I'm decreasing my number. Thus, I'm going to use minus. So 170 becoming 140, I need to subtract 30. 140 becoming 110, also I need to subtract 30. 110 to become 80, I need to find the pattern as well, and I realize that it's still negative 30. So now I see that my numbers on the left side, the rate of change is constant, and so does the right side. Another word you can also say, as the number of transactions increased by 3, the balance in the account decreased by $30. Since the rate of change is constant, this is a linear relationship. The constant rate of change is looking at the rate of change, you will have negative 30 over 3. Or if you simplify, it becomes negative $10 per transactions. This means that each transaction involves a $10 withdrawal. For the next problem, is a relationship a linear? If so, find the constant rate of change. If not, explain your reasoning. So let's practice just one more time with a table, and later we'll practice with the graph. This table, also we're going to find what's happening as I'm going down. So for example, starting with the 5. 5 becoming 10, I need to increase by 5. 10 becoming 15, increase by 5. And it looks like it's also adding by 5. Looking at the temperature, 95 Fahrenheit became 90 degrees. So it looks like it's decreasing by 5, from 90 becoming 86. For this one, on the other hand, actually looks like I'm decreasing by 4. I'm not gonna continue for my next number. Instead, I can conclude my decision saying that this is not going to be not a linear, because why am I saying it's not going to be linear? The reason is because even though my numbers on the left side are constant, my numbers on the right side, the rate has changed. Because the CRC, the constant rate of change, is not happening, I cannot say it's a linear. Looking at the part B, when I'm having a graph, the graph is a little bit easier because if you remember the definition of linear relationship, it should have a word line in it. So if I connect, assume that I'm connecting these lines, do you think it's going to be a line graph? To prove that point, well, let me use my tool. I have a line tool that I could connect them. It looks like I don't have any curves or changing my direction, so I can say, yes, this one is a linear because it has a line graph. I could conclude that. If you want to find the constant rate of change from the graph, I can also talk about that in the future. The third vocab that we're going to look into is proportional linear relationship. Let's say you have quantities A and B. Two quantities A and B have a proportional linear relationship if they have a constant ratio and a constant rate of change. Let's say you found 1/2. And with this, the other ratio happened to be just 2/4. Right now, it might look different, but actually if you simplify this 2/4 divided by 2, you will still get 1/2. So just make sure that you simplify your fractions as much as you can, and then you can compare. If you want to determine if two quantities are proportional, compare the ratio for several pairs of the points to determine if there is a constant ratio. So let's look into an example. Number 2, use the table to determine if there is a proportional linear relationship between a temperature in degree Fahrenheit and a temperature in degree Celsius. Explain your reasoning. When they say proportional linear relationship, it's not much different than when you just have a linear relationship. So for example, let's just repeat what we have done. The first one I see are degree in Celsius. From 0 to 5, if I'm looking at the numbers, it looks like it's increasing. So I'm going to add by, well, 0 to become 5, I need to add by 5. 5 to become 10, adding 5. 10 to 15, adding 5. And the last one, also 5. So you notice that my numbers are constant for degree in Celsius. I just need to compare one more time for the bottom numbers. For the degree in Fahrenheit, 32 became 41. So still I'm increasing by 9, and 41 became 50, increasing by 9. Oh, it looks like I'm still adding by 9 and 59 to become 68. If you're struggling, you can also do backwards. So 68 minus 59, the difference becomes 9. So you can think this way, 59 plus 9 is still giving you 68. So as you see, my numbers are constant. So I could say yes, it is proportional linear relationship because the reason is because, as you see, my numbers as I go to the right, they are all constant. Just to find the actual number, it's going to be change in Fahrenheit over change in Celsius. That's how I can get 9/5. I can tell you a little bit more later about how do I know which number will go on top. The last example, use the table to determine if there is a proportional linear relationship between mass of an objective in kilograms and the weight of the object in pounds. Explain your reasoning. When you're comparing from the table, This time I'm going to compare with the pairs. So for example, when I have 20 pounds, I have 9 kilograms. When you had 40 pounds, I had 18 kilograms, and so on. So let me look into these numbers. 20 over 9. Compare with 40 over 18. I need to make sure, are they same ratio? In order to prove it, let's see if I can simplify this. So 29, there's nothing I can do. However, the 40 and 18, they have greatest common factor as 2. So if I divide this one by 2, 40 divided by 2, I get 20. 18 divided by 2 as well, I get 9. So I've noticed that 20 over 9 is same as when I had 40 over 18. Just to make sure, I want to do one more. So for example, let's pick 80 over 36. 80 over 36 doesn't look even close to 20 over 9, but let's see if I can simplify. Let me start with dividing by 4. So if I divide by 4 on top, I would get 20, and 36 divided by 4, I will also get 9. So you notice that all of those ratios are same. So can I say this is a proportional linear relationship? The answer is yes, it is. Let me just write this way. Proportional linear relationship. The reason is because there could be many different reasons how you explain, but overall you can say that all my ratios are constant. In other words, they are same. The reason I didn't do it this way for the other problem is just because you had 0. When you have 0 on the denominator or numerator, you notice my number either becomes 0 or not possible, and everything else will be 9 over 5. So this is the end of the lesson. Thanks for learning with me.